Hello students, today we will start with the second part of this chapter, that is solutions and solubility. So you already have the idea about these two terms, but here we will learn about these two terms in detail. So what are solutions? Simply we can say that solution is a homogeneous mixture of two or more substances. So these substances can be of any state, they can exist in any phase, it can be solid or liquid or gas. So a solution is a homogeneous mixture of two or more substances. Now what does this term homogeneous mean? So homogeneous mixture means the solution where or the mixture where the distribution of the particles is same throughout the solution. Okay, if we take a 10 ml solution of sugar solution, that means all the particles of sugar in that 10 ml of water is same throughout that 10 ml, right? So this means the homogeneous mixture. That means throughout the solution the distribution of the particles is same. Now some common examples of solutions are salt solution, sugar solution, some metal alloys are there. Air is also a homogeneous mixture. There are various types of gases present in air, so it is also a homogeneous mixture. Okay, so these are the homogeneous examples of homogeneous mixture. Okay, now here it is mentioned that a solution is a homogeneous mixture of two or more substances. So when a solution is made up of only two components, in that case it is called the binary solution. Okay, it is called binary solution. That means it contains only two components. Okay, now when it is more than two, that means if the solution contains three or four components, mainly in that case it is called quaternary or ternary. Okay, like for three components it is called ternary. Okay, and quaternary in that case there are four components present in the total solution. So what are these components? A solution is basically, in case of the binary solution, it can be explained easily that in a particular solution it is made up of two components for binary solution, and those components are termed as solute and solvent. So simply we can write that solution is made up of solute and solvent. Okay, so what does these two terms mean? What is solute and what is solvent? See, in a particular solution, the substance which is dissolved, it is called the solute. The substance which is dissolved, it is called the solute, and the substance in which the solute is dissolved, it is called the solvent. So let's take an example. For the salt solution, salt is dissolved in water, right? So in that case solute is the salt, and as the solution is of aqueous solution, that means salt is dissolved in water, so as the solute is dissolved in water, so that water is called the solvent. Clear? And the mixture of this solute and solvent is called the solution. So in the salt solution, the particles of the solute are uniformly distributed throughout the solvent, and in that case it is called the homogeneous mixture of solute and solvent, and it is a solution. Clear? There are various types of solution depending on the various types of solute and solvent. So when both the solute and solvent are solid, that type of solution is called the solution of solid in a solid. And we can say that there are certain alloys in which two different types of metals are combined in their molten state, and again they are cooled down to form the alloy. In that case, it is called the solution of a solid in another solid. Okay. The next type is solution of a solid in a liquid. This is the most common type of solutions. Here we can take the examples of the sugar solution, salt solution, etc. So here we can take the example of salt solution or sugar solution. Okay, now there are again some different types. We will discuss those names later. So here both the salt and sugar are the solutes and they are dissolved in the solvent, which is water. So whenever any solute is dissolved in water, that type of solution is called the aqueous solution. I will discuss it later. So first let's proceed with this types of solution. Next is the solution of liquid in a liquid. In this case, we can take the example of vinegar. You have already gone through, or you have already smelt, or you know that what is vinegar, right? It is generally used in cooking or some other preservation techniques. So vinegar is a solution of acetic acid, which is an organic acid, and in the solvent is water. So we can take the example of solution of liquid in a liquid as vinegar. Here acetic acid is dissolved in water. So acetic acid is a liquid and water is also a liquid. So this vinegar is the example of solution of liquid in a liquid. Next is solution of gas in liquid. So we can take the example of the aerated drinks like soda water or some other cold drinks, soft drinks mainly. So they are the examples of the solution of gas in liquid, because in the aerated drinks generally we mix the carbon dioxide gas in the solvent. Okay, so we can take the example of soda water. Here carbon dioxide is the gas and it is mixed in the solvent, that is water mainly. Okay. Next is solution of gas in a gas. This is mainly the air. Air is a solution of gases like oxygen, carbon dioxide, nitrogen, and various gases are there. Sulfur dioxide, sulfur trioxide, many oxides of nitrogen are there. So as it is the homogeneous mixture of different gases, the main example or the important example of the solution of gas in a gas is air. Clear? Now there are some different or special names are given to the solutions depending on the name of the solvent or depending on the solvent. For example, I just mentioned what is aqueous solution. So first kind is aqueous solution, where the solvent is mainly water. Okay, so here solvent is water. Whenever the solvent is water and any other substance is mixed in water, in that case the solution is called the aqueous solution. Another type is non-aqueous solution. So what are they? The solvent other than water, they are called the non-aqueous solvent. For example, alcohol is another type of solvent, carbon disulfide is another type of solvent, liquid ammonia is another solvent, benzene, ether, sometimes petrol also. So whenever the solvent is other than water, these are called the non-aqueous solution. For example, benzene, any alcohol like spirit or some different types of alcohols are also there. Ether is another type of solvent. These are the organic substances. They are called the organic solvents. Okay, you can also name them as organic solvents. Now what are these organic and inorganic? You will learn it later in the next standard. So just now keep it in mind that they are the organic solvent. Some other examples are carbon disulfide, petrol, ammonia, This is not the organic. Okay, these are the organic solvents, and liquid ammonia is the inorganic one. Another type of solvent is called the tincture. It is another type of non-aqueous solution, and it is called tincture because in this case the solvent is mainly alcohol. Okay, so whenever the solvent is alcohol, the solution is termed as tincture. Like we say iodine tincture or tincture of iodine. In that case, iodine is dissolved in alcohol. Okay, so for example, we can say iodine tincture or tincture of iodine. Clear? So this was all about the various types of solution. Now we will learn about the various properties of the solution. There are various important characteristic properties of a solution which we will discuss now. So the first point we can say is that a solution is a homogeneous mixture. As we have seen in the definition, we have given the definition that a solution is the homogeneous mixture of two or more substances. So the first characteristic property is a solution is a homogeneous mixture. The next property is regarding the size of the solute particles. So when the size of the solute particles in a solution means generally in a solution the size of the solid particles are extremely small, okay, and it is less than 1 nanometer in diameter. So 1 nanometer means 10 to the power minus 9 meter. 1 nanometer is equal to 10 to the power minus 9 meter, okay, and the size of the solute is less than this 1 nanometer. You can imagine how small are they. So whenever a solution is there in which the size of the solute particles is less than 1 nanometer, or we can say it is near about 10 to the power minus 10 meter, in that case they are called the true solution. So the size of the solute should be less than 10 to the power minus 9 meter, or it should be near about equal to the 10 to the power minus 10 meter. Okay, so they are called the true solution. Thus we have to say that another property of the solution is the size of the solute particles. So we will write the size of the solute particles should be less than 1 nanometer. Okay, so if the solute particles size is less than 1 nanometer, in that case we will call it as the true solution. So another property of the solution is about the size of the solute particle. Okay, now as the solution is a homogeneous mixture, that means the solute particles are uniformly distributed throughout the solution, so we can say that a solution is clear and transparent. It is not opaque because all the solute particles are equally distributed. If the distribution was not equal, in that case the solution will not be clear and transparent. Okay, so whenever the solution is true solution, in that case it is a homogeneous mixture of two or more substances, and in that case the solution is clear and transparent. Next characteristic property is it does not scatter light. That means a solution, mainly we are talking about the true solutions. Okay, so a solution does not scatter light. So why is this so? This can be explained on the basis of the size of the solute particles. As the particles are very small, in that case it does not scatter the light. So for the scattering of light we need the huge particles. Okay, as the particles are very small, they do not scatter the light. Okay, next thing is the particles or the components of the solution, they cannot be separated by simply filtration. Okay, so filtration is not the technique in which we can separate out the components of the solution. So here it is, the particles cannot be separated by filtration. As the particles are very small, if we want to filter it, those particles of the solution, it will pass through the filter paper. So it's difficult to separate the components by filtration. Okay, we can use some other techniques to separate out the particles, but simple filtration won't serve our purpose. The next point, that is the characteristic of the solution, is the solute particles in a solution does not settle down. As I said that the particles are uniformly distributed throughout the solution, throughout the solvent. So those solute particles, they do not settle down in a particular solution. So these are the important characteristic properties of a solution, and you need to keep them in mind, because from here again some point wise questions or 1 mark or 2 mark questions can be given, can be set in your question paper. So please go through these points carefully. Okay. Two another types of solution are there which are very common, that is concentrated solution and dilute solution. A solution is said to be concentrated whenever the solute is comparatively larger than that of the solvent. Okay, and in case of the dilute solution, the solute is present in smaller amount as compared to that of the solvent. So we can write here, in case of concentrated solution, the amount of solute is more than that of the solvent, and here in case of the dilute solution, the amount of solvent is more than that of the solute. So this is all about the concentrated solution and dilute solution. Now we will learn about the saturated solutions and the unsaturated solution, or the supersaturated. Some other type is there, that is the supersaturated solution. We will discuss it one by one. First, we will learn about the saturated solution. So a saturated solution is that solution in which no more solute can be dissolved at a particular temperature. Okay, here in case of the saturated or unsaturated or supersaturated solution, the term temperature is very important. Okay, so keep it in mind that a solution in which no more solute can be dissolved at a particular temperature is called saturated solution. For example, we can take if in a for the aqueous solution, okay, let's take the example of the aqueous salt solution. So if in an aqueous salt solution no more salt can be dissolved at a particular temperature, let's take the temperature of the room temperature only. Okay, so whenever we are adding salts in the water, so when no more salt can be dissolved at room temperature, in that case that solution will be called as the saturated solution. So a saturated solution contains the maximum amount of the solute which can be dissolved in it at a particular temperature. Clear? So it is obvious that a saturated solution contains greater amount of solute than an unsaturated solution. So what is the unsaturated solution then? Here it is just the opposite of the saturated solution. Okay, that means a solution in which more, here we have said that no more solute can be dissolved. So in case of the unsaturated solution, a solution in which more quantity of the solute can be dissolved without raising its temperature. Okay, that means at a particular temperature only we will dissolve the solute in the solution, in the solvent. So whenever more and more amount of the solute can be dissolved in a particular solvent at a particular temperature, in that case that solution is called the unsaturated solution. So in an unsaturated solution, it contains lesser amount of the solute than the maximum amount of the solute which can be dissolved in a particular temperature. Okay, so this is all about the saturated solution and unsaturated solution. Now as I said that please don't forget to mention this term, that is temperature. Here temperature is very important because both the saturated and unsaturated solution, they depend on a particular temperature. If we change the temperature, the solubility of the solute in the solvent will change. So now we will discuss that what are the effects of heating or cooling on a saturated solution. See, a solution is saturated at a particular temperature only. Okay, we have mentioned that a saturated solution is that solution in which no more solute can be dissolved at a particular temperature. So a solution is saturated at a particular temperature only. Now if the saturated solution at a particular temperature is heated, okay, so if we heat that solution to a higher temperature, in that case that saturated solution will turn to unsaturated solution. That means that solubility of the solute in the solution will now increase. Okay, now why does this happen? Why this saturated solution turn to unsaturated one on increasing the temperature? This is because the solubility of the solutes, it increases on heating, and more of the solute can be dissolved if the temperature is increased. Clear? So on increasing the temperature, the solubility of the solute increases and thus more solute can be dissolved. So the saturated solution turn to unsaturated solution on heating because a solution is saturated at a particular temperature only. Okay. Now what will happen if the solution, that is the saturated solution, is cooled? So if a saturated solution available at a particular temperature is cooled to a lower temperature, that means while heating we just increased the temperature and on cooling we will decrease the temperature. So on cooling some of the dissolved solute will separate out in the form of solid crystals. Okay, so if the saturated solution is cooled, it will turn to the crystalline form. This is because the solubility of solute in a solution, it decreases on cooling. Okay, it is just the opposite of this phenomena. So on cooling, the solubility of the solute in a solution decreases, and thus we can say that if a saturated solution at a particular temperature is cooled down, then some of its dissolved solute, it will separate out to form the crystals. Okay. Now a saturated solution can also be made unsaturated if we add more of the solvent to it. Okay, so if we change the amount of the solute and solvent, then we can change the saturated or unsaturated property of the solution. Okay, another type of the solution is the supersaturated solution. See, in a saturated solution we can say that a particular solute, okay, every solute has a particular solubility in a given solvent at a particular temperature. For example, if we dissolve sodium chloride, that is common salt, in water, then experimentally it is found that a maximum of 36 grams of sodium chloride, that is NaCl, it can be dissolved in 100 grams of water at a given temperature, that is 20 degrees Celsius. So these are the conditions, that is 36 grams of sodium chloride can be dissolved in 100 grams of water at 20 degrees Celsius only. So 36 gram is the maximum amount. No more sodium chloride can be added at 20 degrees Celsius to the 100 gram of water. So this will form the saturated solution. Now if we can add more amount of solute, or we can say that if a solution contains more amount of solute than the theoretical value, then that type of solution is called the supersaturated solution. We can prepare the supersaturated solution by heating the saturated solution, because on heating we have said that saturated solution will turn to unsaturated one. So if we heat the saturated solution, then we can add more amount of solute, and then again if we cool that solution, then we can say that at room temperature more amount of solute is now present in that solution, and now that solution will be called as the supersaturated solution. Is it clear to you? So in case of supersaturated solution, we can say that more amount of solute is present than the saturated solution at a given temperature. So this was all about the saturated solution, unsaturated solution and supersaturated solution. Now we have to learn some numerical problems based on the concentration of a solution. So what is the concentration of a solution? It is the amount of solute dissolved in a given quantity of the solution. Okay, so this concentration of solution, it can be expressed in many ways like mass percentage, volume percentage, etc. And we have to solve some numericals based on this mass percentage and volume percentage of the solution. So first we will learn how the concentration of the solution is represented in terms of the mass percent. Okay, the mass percent, it is basically considered in case of the solid in liquid type of solution. Okay, that means where the solute is in solid state and the solvent is in liquid state. And this mass percent, it can be determined we can say that this mass percent is found in case of the solute which is in solid state. We can express it in this way, that amount of solute in grams present in 100 grams of the solution. Okay, so it is represented in this way. So the concentration of solution, that is the mass percent, it is given in this way. The amount of solute presented in grams. So it is the mass of solute represented in grams by the mass of solution. Here it is the solution, keep it in mind. That means it is the sum of solute and solvent. Okay, so mass of solute by mass of solution into 100. In this way we can represent the mass percent of a particular solution. Let's take an example. Here is the question that a solution contains 30 grams of sugar dissolved in 370 grams of water. So calculate the concentration of this solution. How to solve this? See what are given here. The mass of solute is given. Okay, so we can solve it. Mass of solute, that is mass of sugar, is 30 grams here. Okay, now mass of solvent is 370 grams. So what will be the mass of solution? It will be the mass of solute and the sum of the mass of solute and the solvent. So it will turn to be 30 plus 370. This is the mass of solution. Okay, that means this is 400 grams. Now we need to find the concentration of the solution. So again we will use this formula, that is the concentration of solution is given by mass of solute by mass of solution into 100. So we have the mass of solute, that is 30 grams, mass of solution, that is 400 grams, and we will multiply it to 100. Therefore concentration of solution is equal to mass of solute, which is in grams, by mass of solution, which is again in grams, into 100. Okay, so this will turn to be near about 7.5%. Okay, so this is the concentration of solution in this case. Clear? Another term or another type of the concentration of solution can be represented in terms of volume percent. Okay, so this volume percent is basically used in case of the liquid in liquid system. That means the solution where both the solute and solvent are liquids. So what is this volume percent? It is same as that of the mass percent, but here it is expressed in terms of volume. So it is the volume of solute in milliliters present in 100 milliliters of a solution. So it is given by the volume percent is equal to volume of solute in milliliters by volume of solution. Here again it is the sum of the volume of solute and solvent. Okay, it is presented or represented in terms of milliliters into 100. Let's take another example of volume percentage. So the question is, a solution contains 50 ml of alcohol, that is the solute. Okay, mixed with 150 ml of water. This is the solvent. Calculate the concentration of this solution. So how to solve it? Simply we will use this formula. So here volume of solute, that is alcohol, it is 50 ml, and volume of solution, it is the sum of these two, solute and solvent. So it will be volume of solute is 50 and volume of solvent is 150. So it is again 200 ml. Okay, now we will find out the volume percentage. So the concentration of the solution, it is equal to volume of solute, here it is 50 ml, and volume of solution, it is 200 into 100. Okay, simply it is 25%. Okay, so the concentration of this alcohol solution is 25%, or it can be said that it is the 25% alcohol solution by volume. Okay, so in this way we will calculate the mass percentage and volume percentage. Okay, this type of numericals, they carry 2 marks, and in that case you have to write the formula first and then you have to put the values. Okay, so here as I have mentioned it just above the equation or just above the question, so I have not written it here. But in case of the exams, while you will solve the numerical in exams, you have to write this formula first, then you have to put the values in that formula, and then you have to calculate the answer. Then you have to write the answer also. Okay, so in this way you will get the full 2 marks which is allotted for this question. Clear? So this was all about the solution. Now we will learn about the solubility. See, when we were discussing the heating or cooling effect on the saturated solution, we said that when we are increasing the temperature, the solubility of the solute increases, and on decreasing the temperature, the solubility of the solute decreases. So what does this term solubility it mean? The solubility can be expressed in terms of the solute only. So the maximum amount of a solute which can be dissolved in 100 grams of a solvent at a particular temperature, it is called the solubility of that solute in a particular solvent at a given temperature. So again you need to mention the temperature condition and the type of solvent also. See, different solutes dissolve in different solvents. So here we need to mention the type of solute and type of solvent also, and again the temperature condition is important. So how to define the solubility? It is the maximum amount of a solute which can be dissolved in 100 grams of a solvent at a particular temperature, then it is called the solubility. So if the solvent is water, then we can define solubility as the maximum amount of a solute which can be dissolved in 100 grams of water at a given temperature is the solubility of that solute in water at that temperature. Okay, now when any substance or any solute which is negligibly soluble in a particular solvent, that means the solubility of a solute is almost nil in a particular solvent, in that case the substance is called the insoluble substance. For example, silver chloride, it has near about 0.30 or 4015 gram as its solubility. So we can say that silver chloride is almost insoluble in water. Okay, so generally in aqueous solution, silver chloride is formed as the precipitate, that means it is insoluble solid. Okay, on the other hand, if the substance that has more than negligible but less than highly solubility, it is called the sparingly soluble, that means it is partially soluble in the solvent, mainly in water. So the substances which are negligibly soluble in water, they are called insoluble substances, and the substances which are partially soluble in water, they are called the sparingly soluble. Here I explained in terms of water as the solvent, but it is true for any solvent. Okay. So the soluble substances are those which have high solubility. For example, any salt like copper sulfate or magnesium sulfate or sodium chloride, potassium chloride, they are highly soluble in water, but silver chloride is insoluble in water. Okay, and some substances are there like calcium hydroxide, it is sparingly soluble or partially soluble in water. Clear? So I have started the topic solubility today, but in the next class I will discuss the solubility and its different properties, the solubility curve, and all the terms related to solubility in detail. Okay, so this is all about today.